Lesson 7.2, Applications of the Normal Distribution. The objectives for this lesson is to be able to find and interpret the area under a normal curve, and then find the value of a normal random variable. Before we begin, I want to just cover the complement rule, which was in lesson 5.2. So just in case you do not remember or you didn't have this lesson, the complement rule is 1 minus the probability of E. So say that the probability of owning a dog is 0.25. I want to find the complement of this. So the probability of not owning a dog. You can do 1 minus the probability of owning the dog. So the probability of owning the dog is equivalent to your 0.25. So the probability of not owning a dog is just 1 minus the 0.25 to get the 0.75. So we have worked in chapter 3 on z-scores, and if you recall, to get a z-score, you take x minus your mean or your standard deviation. So this is for a population. So for the symbols for a sample would be x minus x bar over s. Let's get back. Not sure what happened there. And that was in chapter 3. So we use z-scores to find the area under a normal curve by hand. The z-score allows us to transfer a random variable x with mean mu and standard deviation sigma into a random variable. Z-scores have mean 0 and standard deviation 1 always. So here we have two normal curves. We're going to go back up to the cholesterol example. The mean was 180 degrees and the standard deviation was 36.2. We're working with the variable x, and then over here we're going to do z-scores. So first let's plot these. One standard deviation down was 143.8. One standard deviation above was 216.2. Just take the mean and add a standard deviation, and then subtract a standard deviation. And we were curious about cholesterol of 200, which was somewhere in here. Now you can do that and convert it to z-scores. So z-score always has a mean of 0, standard deviation of 1. So if you subtract, we're to -1 here, and then add standard deviation, we're up 1. So what we need to find is the z-score for 200. So follow the formula put up here. 200 minus the mean, which is 180, over the standard deviation. So when you do this on your calculator, you should get 0.55. And then where about is 0.55? About right here. And you can see that these match identically, except for obviously the horizontal labels. So always know that the z-score has a mean of 0 and a standard deviation of 1. How do we find the area to the left or to the right of a normal distribution with a variable x? We would use calculator command number 6 on our calculator sheet. Finding the area probability under a normal curve. And here are the steps. Let's look at an example. A pediatrician obtains a height of her 203-year-old female patients. The heights are approximately normally distributed, with mean of 38.72 inches and the standard deviation of 3.17 inches. Use the normal model to determine the proportion of the 3-year-old females who have a height less than 35 inches. That is, find the probability that x is less than or equal to 35. We would assume that this is normally distributed after or as the sample increases because heights is a natural occurrence. Remember, anything that naturally occurs will have a normal distribution. So let's plot our mean and our standard deviation like we did up above. And then 3.17 is our standard deviation. So if you subtract, we get 35.5. Then you add. We get 41.89. So we want to know x is less than or equal to 35. So find 35 on here. And then less than is everything to the left. So I'm doing this for x variables. You could have converted this to z's, just like up here, and follow your calculator commands. So let's find the probability that x is less than or equal to 35. So we're going to go to second vars, normal CDF. Type in values for the lower bound. So if we're missing a lower bound, you can see it keeps going on and on and on. We're going to type in negative 99999. Then the upper bound, so how high are we going? We're going up to 35. This red is 35 because of this. So 35. And then our mean was 38.72. And then our standard deviation was 3.17. So it's 0.1203. So this shaded area is 0.1203 or 12%. All right. Now, what if we wanted to do this in z-scores? So again, mean is 0, 1, and 1 for standard deviation. Now the z-score, we're looking for 35 minus the mean divided by standard deviation. So our z-score is negative 1.17. So about right here, negative 1.17. So you could follow the same thing on your calculator. Lower bound, still negative 99.999. Keep going with that. Little side tip, if you put too many 9s in here, you're going to get an error. So if you're getting an error, just cut back on your 9s. Upper bound is negative 1.17. What is the mean of your z? 0. Standard deviation is 1. Okay. We're fairly close. The only reason why we're a little off is because we rounded this negative 1.17. if you keep writing the whole z-score that you found out, and then 0, 1 for mean and standard deviation, you're going to get to 12.1203. So rounding errors could be it if you don't see it. So you can either do the z or the x when you find these probabilities. Okay, so let's see how close this calculation is to the actual amount. So we're checking. So we are doing less than 35 or equal to. So we're going to add those up. When you add those up, you get 0.115. That is very close to that. So you can see that this is a good method. And then just for a explanation or in sentence, if we randomly selected 100 3-year-old females, we would expect about 12 of them to be less than 35 inches tall. If we wanted to know the proportion of 3-year-old females whose height is greater than 35, so now we're looking for the probability that x is greater than 35, we could use the complement rule. So we could do 1 minus the 0.1203 to get 0.8797, or you could use your calculator. I will show you by calculator. Second bars, lower bound now is 35, upper bound is positive 99999, mean is 38.72, and standard deviation is 3.17, 0.8797. So you can do it either way. Moving on to percentiles. Because the area under the normal curve represents a proportion, we can also use the area to find percentile ranks of scores. In the example above, 12% of the females have a height less than 35 inches, and 88% of the females have a height greater than 35 inches. So a child whose height is 35 inches is in the 12th percentile. So what we're looking at here is the percentage to the left, or less than 12%. Matches up with the percentile. Use the normal model to determine the probability that a randomly selected 3-year-old female is between 35 and 40 inches tall. Okay, again we have our height of 38.72. And now 35 is over here, and 40 is somewhere over here. So we want the area in between. So now we would just do, our lower bound is 35, upper bound is 40, mean is 38.72, and our standard deviation is 3.17, giving us 0.5365. Let's go back to the table and verify that this is close to the actual amounts. So between 35 and 40. When you add those up, we get 0.55, and that is very close to the 0.5365 that we received.